Okay, we have hard problem today. Given some list of numbers, we want to find how many subsequences and like this. The pairs of subsequences have the same greatest common divisor. And the greatest common divisor is that if we have two numbers like 3 and 6, we have the greatest divisor of 3 is 3 and of 6 is 6 and 3 and 2, but we want common. Common is, so it is 6, 3, 2, 1, and the common is 3. So we want to find how many such subsequences that has the common GCD equal. And subsequence is that we can take or skip any number and they shouldn't intersect. So this problem is hard. Size of the problem 200 elements and 200 maximum inside. And if you want to I personally gave up after 6 minutes just because I don't feel like I can solve it. But if you look at the hint, it tells you this is dynamic programming problem, and you can depend on the state of the current position, like this. Or if we have big entire array, we can solve it for the subproblem, and subproblem is array ending at particular index. And the second state is GCD of first subsequence and then GCD of second subsequent. By the way, the GCD of several numbers, so we have GCD of two numbers, but what about like 3, 6, 5, 3 numbers? And that's just taking GCD recursively, like GCD of 2 first, then GCD of the next. This is how you solve it for several numbers. And that means if you have this GCD defined, that means the application of all subsequence equal this GCD. So inside it we have some numbers chosen for the first one and some numbers for the second one, and the GCD are like this. And when we solve it for this DP, when we fill this table, we can just take it like sum of DP of every I element, and then we have equal GCD. So basically JJ should be the same. It should be equal. So when I saw this hint about the DP, I just immediately know the solution. You can do depth research, and it is knapsack problem. Just take it or skip it. You have two GCDs and you have position, and when you're at finish line, you look if your GCD 1 and 2 equal, then it is 1. And if it's not equal, then it is 0, because we are not taking this case. Then inside you have to use the previous GCD and add the number for the first one, add for the second one, or skip. And then you do take a sum this is 3 possibilities: take 1 or take 2 or skip. And I also spent about 15 minutes just to fix some bug that I initially wrote this as 200 times 200 for the k, and it is not correct because 200 is inclusive, and I have to do 201. Also, this is -1, and it is just magic for me still, because I just look at the answers and they are all offset by 1. I still don't know why we don't take in 1. Maybe it is a 0 case where we take 0 GCDs and 0 elements, basically empty. But I don't know, I'm not sure about it. Let's look at bottom-up solution. It is interesting. This is how it looks in Rust. For the bottom-up, you fill this filling up the same table. So we have TP I, and this would be table for GCD1, GCD2. This is 2D table. You can, as I wrote in this code, I make it flat, but it doesn't matter. And as we move for each element forward, we have this previous table. So we're only interested in the previous one, so we don't have to store this dimension. So we can store just one. GCD by GCD, it is 201 times 201 size table. Basically, we have this table, and it is from 0 or up to 201. Same here. And if we have some value like this, for example, would be 7. I don't know, it's just out of my mind. That means at GCD, GCD1 and GCD2 equals some other. So equal x equals y. We have 7. 7 it is a count of subsequences. Basically the answer of how many subsequences we have that has GCD1 equal x, GCD2 equals y, and we fill in it, and it became some fill table. And finally we do diagonal sum, because this is where we have GCD1 equals GCD2, like this, basically our answer. Let's look at the code. So I'm iterating flat, and I fill in the next flat table of GCDs, and this is a, if I take the element to GCD1, this is how many steps would I have from the previous one, and this for the next one. And this is a final step. This is diagonal I times 201 plus I. Okay, that's it for today.